Good morning friends, welcome back to Pannika Tutorials. In the last lecture, I have discussed what is a circular cube and how it has overcome the limitation of the cube. I hope you have watched that lecture. If you did not watch it, I request you to go back and watch that video and come back to this video. Circular cube can be implemented using the arrays and also using the linked list. So in this video, I want to discuss how to implement the circular cube using the array. In the next video, I will discuss using the linked list. So I request everyone to watch the complete video for better understanding. First, let me discuss an overview about the circular cube. Then I will discuss its implementation using the array. Let's assume that you have declared an integer array of size 5. Now, you have a circular cube which is logically represented like this. It will be in circle in nature. Okay, that's why it is called as a circular cube. Now, always you know that array index will start from 0 and it will go up to size -1. So, this is about the circular cube. Now, the circular cube is indexing is start from 0 and it is going up to 4, and then again you can come 0, 1, 2, 3, 4. So, that's why it is circular in nature. Now, let me discuss the few conditions like how can you check whether the circular cube is empty, how can you check the circular cube is full. All these things we will discuss. We will have two variables called front and rear. Already we have discussed them in the queues also. Now you know that in a circular queue or in a queue we will have two operations. One is the enqueue and the dequeue. What is meant by enqueue? Inserting an element into the circular queue we will call it as a enqueue. Dequeue is deleting an element from the circular queue is called as dequeue. Now, what is the purpose of front and rear? The front will be useful for you to know the first element in the queue, and rear will be pointing to the last element in the queue. Okay. So, if it is a simple queue, okay, front will be pointing to the first element. Let's take that you have elements 2, 3, 4. Then rear will be pointing to here. So, the dequeue operation will be done from the front. Enqueue operation will be done from the rear. Is it clear? Now, initially front and rear is equal to -1. Then you can say that circular queue is empty. Is it clear? Now, let's take that we are writing the or inserting the elements such as 2, 20, 30, 40, 50. These are the elements I want to insert into the circular queue or enqueue into the circular queue. Now, when front and rear is equal to -1, then queue is empty. Is it clear? Now, when the queue is empty, if you are inserting the element 2, then this is the first element. Am I right? If this is the first element, what we will do is that front and rear, we will make it is equal to 0. Okay? In the name of the array A, at the index of rear, we will keep the value 2. Is it clear? This is the value you want to insert into the circular queue. So, front and rear is equal to -1. The circular queue is empty. If you are performing the enqueue, then whatever the element you are inserting, that will be the first element. Then you will make front and rear is equal to 0. At the rear index in the array A, you will insert this element. So, now this value is 2 at the index 0. Now, front and rear is equal to 0. So, both front and rear is pointing to this element. Is it clear? Are you able to understand it or not? Now, you want to enqueue the element 20. Now, whether the queue is empty? No, there is a one element. That's why front and rear is equal to 0. Am I right or wrong? Then, if you want to insert another element which is 20, what we have to do is that we have to increment the rear. Because if you are inserting the element 20 here, the first element is 2. Now, rear should point here. That's what we have discussed. The first element in the queue will be pointing by the front and the last element will be pointing by the rear. Is it clear? Now, how can we do the insertion? If it is a queue, we will say rear plus plus and A of rear is equal to 20, we will say. This is the simple queue, how we can do the enqueue operation when the queue is not empty. But when it comes to the circular queue, how we should write is that rear is equal to rear plus 1 modulus size. Here the size is the size of the array. Okay, now let me take the example. Now what is the real value? Real value is 0. So 0 plus 1 modulus, what is the size of the array here? 5. So 0 plus 1 is 1, 1 modulus 5. You know that modulus operator will give the remainder. 1 modulus 5, you will get the remainder as 1. So real value will become 1 now. Now you have to do a of rare is equal to 20. Then value 20 will be inserted at the index 1 and rare is pointing to that 1. So now front is equal to 0, rare is equal to 1. Now you are inserting another element 30. Now look at this one. Rare is equal to rare plus 1. What is the rare value? Now 1. So 1 plus 1 modulus 5. 1 plus 1 is 2. 2 modulus 5 is 2. Now rare value will become 2. A of rare, which is A of 2, you are inserting the element 30. Or you are assigning the element 30. So here 30 will come. Is it clear? Now you are performing the NQ40. So again these two steps will happen. Rare is equal to rare plus 1, which is nothing but 2 plus 1, which is 3. 3 modulus 5, which is equal to 3. So rare becomes 3. A of 3, which is equal to 40. So 40 will come here. Are you able to understand? Now you want to NQ the element 50. Again, rare is equal to rare plus 1, which is 3 plus 1, which is 4. 4 modulus 5, which is 4. Is it clear? So at A of 4, you are assigning the value 50. So now 50 will come. Now check it, whether Q is full or not. Yes, Q is full. You can insert 5 elements. You have inserted them 2, 20, 30, 40, 50. Now front is pointing here. Okay, rare is pointing here. Am I right? Rare value is 4 and front value is equal to 0. Am I right or wrong? Now look at the DQ operations. Okay. Then we will discuss when we can check circular queue is full or not. What is the condition? Okay. You maybe by this time you can think that, sir, it is same as the queue only. When rare is equal to size minus 1, we say that circular queue is full. That is wrong. I will discuss with an example, don't worry. Now let me discuss the DQ operations. Okay. If I write the DQ, meaning is that I want to delete an element from the circular queue. Now you know that deletion will be always done from the front. Now how we will do it in the simple queue is that we will just increment the front value, front plus plus we will write, then front value will become 1. So logically we have deleted the 2. But when it comes to the circular queue, we should not write only front plus plus. What we should write it is that front is equal to front plus 1, front plus 1 modulus size, where size is the size of the array. Now look at here. Front value is 0. You have written the DQ operation. So 0 plus 1 modulus 5. Okay, which is 1 modulus 5, which is 1. So front value will become 1. So logically you have deleted this element. Is it clear? Now front is pointing to this element. Now look at here. If you call the NQ operation, what is that? You want to NQ the element 60. When it comes to the simple queue, can you do it? No, you cannot do it. Let me discuss with an example. The same example you have at the index 0, index 1, index 2, index 3, index 4 is there. Now you have the elements 20, 30, 40, 50 is there. Front is pointing here and rear is pointing here. When it comes to the simple queue, even this element is, this location is empty, you can insert, but that is not possible. Why it is not possible? In a simple queue, the condition to check whether the queue is full or not, rare is equal to size minus 1. If it is so, then we will say that circular queue is full. Sorry for the, this is queue only. This is circular queue. Now look at this one. Rare value is what? 4. 4 is equal to size minus 1, which is 4 only. So this condition is true. So even this position is empty. You can insert an element, but when it comes to the queue, you cannot do it. But now look at, can we do it in the circular queue or not? What is the circular queue and queue operation? If we do it, we will say rare is equal to rare plus 1 modulus size. Now what is the rare value? Rare value is 4. 4 plus 1 modulus size is what? 5. So 5 modulus 5, you will get the remainder 0. At A of rare, you will assign the value 60. So A of 0 is equal to 60. So here 60 will come. So the limitation which is there in the queue, we have overcome in the circular queue. Now look at this one. Then if it is so, what is the condition to check whether the circular queue is full or not? Is it clear? Now rare is here. Rare value is 0 and front is equal to 1. So what is the condition to check whether the circular queue is full or not? The condition to check the circular queue is full or not is front is equal to rare plus 1 modulus size. If front is equal to, this is the way we will check the equal in the programming. Okay, front is equal to rare plus 1 modulus size. Now what is the rare value? Rare value is 0. 0 plus 1 modulus size is 5. So 1 modulus 5, which is equal to 1. Look at what is front. Front is also 1. So 1 is equal to 1. So now we can say that circular queue is full. Yes, even you can look at like this. Now all the elements are full. Rare is equal to 0 and front is equal to 1. So if front is equal to rare plus 1 modulus size, we will say that circular queue is full. This is to check the condition for the circular queue is full or not. And what is the condition to check whether the circular queue is empty or not? If front is equal to rare is equal to minus 1, then we will say that it is empty. So with this one, I hope you have understood the basic operations of NQ and DQ in the circular queue. Now with this knowledge, we will write a C program to implement the circular queue using the array. To do that one, what I will do is that I will include the header files, hash include stdio.h, and I will include the stdlib.h. What is the purpose of that one? I will discuss later. Why I am including the stdlib.h. Then I need to define the size. So I will write hash define size some 5. Okay. Then I am declaring a circular queue, CQ I am writing of size. Okay. Then I need to declare two variables, int front is equal to minus 1, int rare is equal to minus 1. Then I need to declare the few user defined functions, void NQ, void DQ. This is the function declaration. The function declaration will tell the return type, name of the function, and how many parameters. This function is not returning anything, so that's why I have used the keyword called void, and name of the user defined function is NQ, and even there is no parameters. Here you can write void or you can keep it empty. Then void display, void peak. Okay. Then you have to write the main function. Before writing the main function, let me discuss about the NQ function, DQ function, display function, peak function. Then we will write the main function. Okay. Just I am writing here, but you should write them after the main function. If you don't want to use the declaration before the main function also, you can write it. Okay. So void NQ. So NQ is not, you want to insert an element. So first, if you want to insert an element, you need to declare a variable x. Then you have to ask the user to enter the variable. Am I right? You want to insert one element into the circular queue. So then you have to ask the user to enter the value. Once the user has entered the value, you need to scan it using the scanf function, or you have to read that value from the user with the help of scanf function. Now you have done. Now what you have to do, you need to check whether the circular queue is full or not. If the circular queue is full, you cannot insert any element into the circular queue. Already I have discussed what is the condition to check the circular queue is full or not. If front is equal to rear plus 1 modulus size, then we will say that circular queue is full. Then you can write circular queue is full. Okay, backslash n. Else if, what is this else if is, I want to check another condition. What is that another condition? If front is equal to minus 1, logical end, rear is equal to minus 1, then what is the meaning? The queue is empty right now. If the queue is empty, what I need to do is that I have to make front is equal to rear is equal to 0. I should make front and rear is equal to 0. In circular queue at the index rear, I want to assign the value x. Is it clear? Are you able to understand? Let me draw with an example. You have a circular queue like this. You have the index 0, index 1, index 2, index 3, index 4. You know that initially front and rear is equal to minus 1. So I am checking whether front and rear is equal to minus 1. Yes, if then circular queue is empty. If the circular queue is empty, whatever the value I am inserting, that will be the first element. So then what I will do, front and rear, I will make it 0. At the index of rear, I will insert the value, whatever the value the user has entered. Suppose let's take that user has entered the value 10. The value 10 will come here. Is it clear? Are you able to understand? Now let me write here. Okay, let me erase this one and write the remaining program. Okay, else is nothing but even this condition is false, meaning is that the circular queue is not full, the circular queue is not empty. Then how to insert it? Meaning is that there are some elements in the circular queue. Then what I need to do, rear is equal to rear plus 1 modulus size. Okay, then circular queue of rear is equal to x you need to write, and you close the else. Are you able to understand? You have closed the else and you should close the void enqueue function also. Let me discuss with a simple example. The array index is starting from 0, 1, 2, 3 and 4. I hope it is visible for you. Initially front and rear is equal to minus 1. Now you want to insert the elements 10 and 20 and 30. Now front and rear is minus 1. So then obviously front is not equal to rear plus 1 modulus size. This condition will be false. Why? You can check it. Front value is minus 1, rear value is minus 1. Minus 1 plus 1 will be what? 0. 0 modulus size, which is 5. 0 modulus 5, you will get 0. 0 is equal to minus 1? No. So this condition is failed. If this condition is failed, it will go to the else if block. It will check this condition. Front is equal to minus 1. Yes, this condition is true. Logical end, this condition is true. So if both the conditions are true, then the entire condition will be true. Once this entire condition is true, what are the statements which are there in this block you need to execute? Front is equal to rear is equal to 0. You are making front is equal to 0, rear is equal to 0. Circular queue of rear, which is 0, you are assigning the value x, so you will get the 10 here. Now it is done. Now again you call the enqueue with the value 20. So enqueue you have called and user has entered the value 20. Now look at this one, whether this first condition is true or not. What is the front value? Front value is 0, rear plus 1. Rear value is 0, 0 plus 1 will be 1 modulus 5. 1 modulus 5 you will get 1. So 0 is not equal to 1. So this condition is failed. Even this condition also will be failed because front is 0, 0 is not equal to minus 1 and 0 is not equal to minus 1. This condition is failed. Then it will come to this else block. What is this else block is there? rear is equal to rear plus 1. Rear value is 0. 0 plus 1 modulus 5. Size is 5. Is it clear? 0 plus 1 is what? 1. 1 modulus 5 is what? 1. So now rear is becoming 1. Circular queue of rear at the index 1, you need to insert the value 20. Is it clear? Next value. Again these two conditions will be failed. Again this condition will be true. Means else block will be done. So rear plus 1. 1 plus 1 is 2. 2 modulus 5 will be 2. Rear value will become 2. Now you will insert the value at this location. Now front is 0 and rear is equal to 2. Let's take that you have inserted here in here. Now rear value will become 4. Now you want to check the condition whether the circular queue is full or not. Rear is equal to 4 and front is equal to 0. Now check, look at this condition. Front value is 0 is equal to rear value is 4. 4 plus 1 modulus 5. 4 plus 1 is what? 5. 5 modulus 5 is what? 0. So 0 is equal to 0. So then this condition is true. Then it will display that circular queue is full. So this is the user defined function to enqueue an element into the circular queue. I request you to write down this one. Then we will discuss about dequeue operation. Okay, how to do the dequeue from the circular queue. Okay, let me write the program to do it. Okay, void dequeue. Okay, if I want to dequeue an element, first I need to check whether the circular queue is empty or not. How to check the circular queue is empty or not? If front is equal to -1 and rear is equal to -1, then we know that circular queue is empty. If circular queue is empty, can we delete an element? What is meant by circular queue is empty? There are no elements. If there are no elements, can we delete an element? No, it is not possible. Is it clear? Now, I want to check another condition. Else if front is equal to rear. What is meant by front is equal to rear? When the front is equal to rear, am I right? When it will be when there is only one element in the circular queue, then this condition will be true. Am I right? Suppose let's take that you have only one element, which is 10. Now you know that front value will be 0 and rear value will be 0 when you have only one element at the index 0, because here only the front and rear will be pointing, because this is the first element and this is the last element. In that case, what you have to do, you have to display the user printf %d, the deleted element. You can write whatever you want and you can display the element which you are deleting. Okay, and then what you need to do is that you need to make front and rear is equal to -1. If you delete this element, then you know that circular queue will be empty. What is the condition to make the circular queue is empty? If front and rear is equal to -1, then only we know that circular queue is empty. Then if there is only one element, if you are deleting it, you have to make the front and rear is equal to -1. Else, then what is the meaning? Queue is not empty, only one element is not there, then more than one element is there. Am I right? Let me take this example. 10, 20 is there and 30 is also there. If it is so, front will be 0 and rear will be 2. Am I right or wrong? So then what I should do? Else, I need to increment the front so that logically this element can be deleted. But when it comes to the circular queue, how can we increment? Is that we will write front is equal to front plus 1 modulus size, then printf. Okay. Before that you have to write printf. Let me erase this one and write it properly. Else we will write printf %d. The element you are deleting, you can write the element you are deleting is circular queue of front. Okay, then you have to increment the front value. Front is equal to front plus 1 modulus size. Look at this one, what will happen. Now this else block will be true because front is not equal to -1, rear is not equal to -1. This condition will be failed and front is not equal to rear. So it will come to the else block, print of %d, circular Q of front, circular Q of 0, which is 10. That value will be displayed as an output. Then you are writing front is equal to front plus 1. What is the front value? 0. 0 plus 1, which will be 1, modulus size, which is 5. So 1 modulus 5 will be equal to 1. Now front is becoming 1. So front will pointing to this value. It will be logically deleted. So this is the way you have to perform the DQ operation from the circular Q. So let me close the else block and let me close the void DQ function. So this is about the circular Q DQ. Okay. Now let me discuss about the display function. Okay, displaying what? You have to display the elements which are there from the front and go up to the rear. So let me write the statements. If you want to display the elements which are there in the circular Q, first you need to check whether circular Q is empty or not. How to check it? If front is equal to -1 and rear is equal to -1, you can say that Q is empty. If circular Q is empty, how can you display the elements? You cannot display the elements. Okay. Then before that one, you will declare some variable int I, else. If the Q is not empty, you need to display the elements. So what I will do is that I will write a for loop. Okay. For loop will have the initialization section, condition section, and then you have the increment section also. Okay, then we will write printf %d, the element is circular Q of I. Okay, is it clear? Now look at this one, what will happen? I value is equal to front. I will discuss this program, don't worry. I value is front. Oh, sorry, front value is 1. Am I right? Front value is 1 and rear value is 2. So you want to display the elements from 1 to 2. Now look at here, front value is what? 1. So I value will become 1. Now rear value is 2. So 1 is less than 2. Yes, this condition is true. If this condition is true, you will go and execute the statement print of %d circular Q of I, which is nothing but 1. What value is there at the index 1? 20. 20 will be displayed. Once it is done, you will come to the update section. I is equal to I plus 1, which is 1 plus 1 modulus size, which is 5. So 1 plus 1 is 2 modulus 5. Is it clear? Are you able to understand it or not? 2 modulus 5 is 2. So I value will become 2. Now look at this condition. 2 is less than 2. No, 2 is not less than 2. This condition will be failed. If this condition is failed, it will not execute this statement. But we got only one thing. So we can write that equal to here. Am I right? That is what you may be thinking. But if you write the equal, what will happen? I will discuss with you. Okay. Look at here. If you have more elements, 40, 50, 60 like this. Okay. Now front is here, rear is here. Are you able to understand? Rear is here. This is the last element and front is here. Then you need to display the elements from here to here. Am I right or wrong? Now look at here. What is the rear value? Rear value is 4. Is it clear? And front value is what? Front value is 1. Am I right? So I value is 1. Is it clear? I value is 1. What I will do is that I is equal to front. Am I right? I value is front. So I value is 1. It is okay. 1 is less than rear. What is that one? I value is 1. Okay. Less than rear 4. Is this condition is true or false? What is the rear value? Rear value is 0. Am I right? This is what the rear. This is index 0, this is index 1, this is index 3 and this is index 4. Are you able to understand? Am I right? So this condition will be fail. 1 is less than 0 but 1 is greater than 0. This condition will be failed. So this is the way you should not write. Why you should not write like this is that this is the problem. Am I right? There are 5 elements are there. First time itself the condition is failed. So what you need to write here is that you should write I not equal to rare. Okay. Then here you should write printf %d circular Q of I. Let me discuss with this example. Rear is equal to 0, front is equal to 1. I is equal to front. So I value will become 1. 1 not equal to rear, which is 0. 1 is not equal to rear. Yes, this condition is true. If this condition is true, what are the statements which are there in the for loop will be executed? What is the statement is there? Printf %d circular Q of I. What is the I? 1, which is 20. So 20 will be displayed as an output. I value is 1. So circular Q of 1, which is 20, that will be displayed as an output. Now once it is done, it will go to this one. I is equal to I plus 1 modulus size. I value is 1. 1 plus 1 will be 2. 2 modulus 5 will be 2. Now look at here. Again you will come to this condition. 2 not equal to 0 because I value is 2, rear value is 0. Is it clear? Are you able to understand? 2 not equal to 0, again the condition is true. So circular Q of I, which is 2, okay, what is the value is the 30. So that will be displayed as an output. Then again you will go to this one. I is equal to I plus 1. So 2 plus 1 modulus 5, which is 3 modulus 5, which is 3. So I value will be equal to 3. 3 is not equal to 0. So again this condition is true. Circular Q of I, which is 3. So 40 will be displayed as an output. Then again it will go to this one. I value is 3. 3 plus 1 is 4. 4 modulus 5 will be 4. Are you able to understand it or not? So this condition will be true. 4 not equal to 0. Then circular Q of I, which is circular Q of 4. At the index 4, 50 is there, that will be displayed as an output. Okay. Once it is done, 4 plus 1, which will be what? 5. 5 modulus 5 will be 0. Now I value becomes 0. So now look at here. 0 not equal to 0. This condition is false because 0 is equal to 0, but it is saying 0 not equal to 0. Then it will come out from the for loop. But however, you need to display the 60 also. That's why I am writing printf %d circular Q of I. What is the I value? 0. So it will go to the index 0 of the circular Q array and display that one 60. So this is the way you should write the program. Am I right? To display the elements which are there in the circular Q, you have to write the for loop. You have to take a variable I. You initialize the I value from the front. And you have to write I not equal to rear. I is equal to I plus 1 modulus size. You have to write the printf %d circular Q of I. Then again you have to write it. Okay. Then you have to close the else and you have to close the function. So this is the display function to display the elements which are there in the circular Q. Now let me discuss the peek function. What is the use of the peek function? To display the element which is pointing by the front. Okay. So to do that one, what I will do is that void peek. First I need to check whether circular Q is empty or not. If circular Q is empty, then there is no element which is pointing by the front. Then I should display circular Q is empty. Else, if circular Q is not empty, then I should print the front element or anything. You can write whatever you want to write here, and you have to write circular Q of front, which is pointing by the front. Whatever the value is there in the front, suppose here if front value is 1, circular Q of 1, so 20 will be displayed as an output. So this is the function to display the first element which is there in the circular queue. So these are the 4 functions we have written. Okay, then what we will write it in the main function. Okay, is it clear? Let me write the main function also for your understanding. Void main, I will write int ch while 1, okay, printf, enter the choice, okay, enter the choice, 1 for NQ, 2 for DQ, you can write like this, 2 for DQ, 3 for display, 4 for peak, 5 for exit. You write the \n, then using the scanf function, whatever the user is entering the choice, that you read it. Okay, then you have to open the switch case and pass the ch value. Okay, and then you write the case 1. What is the case 1? NQ. Then you call the function called NQ, and once it is done, you have to come out from the switch case. So you are writing the break statement. Case 2, DQ, then break. Okay, then case 3. Case 3 is what you want to display. So you call the function called display and then break it. Break is useful for to come out from the switch case. Case 4 is peak, break. Okay, case 5 is exit. Okay, so you will write exit 1. So that's why we have included the stdlib.h default. If user has entered any other choice, then you have to write invalid choice. Okay, invalid choice \n. Switch is completed, while is completed, main function is completed. Okay, after that one, you have to write those functions such as void, NQ, void, DQ, all the function definitions I have written that you have to write and execute the program. You will get the program output. Okay, I hope you have understood how to implement the circular queue using the arrays. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.